Right now for business calculus, we're going to have a lot of applications. So let's look at a couple applications of how we're going to go ahead and use this instantaneous rate of change. So here we're going to look at profit first, because profit is something that we're going to look at a lot. And our profit equation is 2x squared minus 5x plus 6. And we want to find first of all, the average rate of change of profit from 2 to 4. All right, so we're going to go ahead, just find the average and see what's going on. And we're going to go ahead and plug in 2, plug in 4, get those y values. And we're going to go ahead and also subtract our x values, which is 4 minus 2. So we end up with 18 minus 4 divided by 2, which equals 7. Now remember, our x values is given profit in hundreds of dollars. Remember, we need to look at units. And so we're looking at $700 per item. And therefore, because it's positive, means this profit is increasing between 2 and 4. Okay? Now let's look at the instantaneous rate of change of profit. So we're looking at x is equal to 2. We want to know the instantaneous rate of change at that value. Now we already figured out our P of 2. So we already have that value, which is 4. And we need to go ahead and figure out our P of 2 plus h. So we go ahead, plug that in, go ahead and FOIL, distribute, do all the things we need to do. And we end up with 4 plus 3h plus 2h squared. And so we're going to go ahead, put those into our second equation. So we're finding the limit as h approaches 0 of our 3h plus 2h squared divided by h, because our 4's end up canceling in this case. And notice that happens fairly often. Also notice that we can almost always, with these quadratics, pull out an h from the top, cancel with an h at the bottom. And so we're really only finding the limit of a part of the top portion of our fraction. So we have the limit as h approaches 0 of 3 plus 2h, but remember h is going to 0, so that part is going to cancel, and we end up with a marginal profit of 3. Now remember, this isn't hundreds of dollars, and so this is $300 per item. Since our answer is positive, it is an increase. If we get a decrease, that means that it is going down. We're having a decrease in profit, which is something we try not to have if we can help it. Let's go ahead and look at our marginal profit here. Our marginal profit is either the increase or decrease of profit at a certain number of items sold. So in this case, when we're looking at the marginal profit at $300 at x is equal to 2. So our profit's increasing by $300 per item when 2 items are sold. And the interpretation is going to be important when you're looking at these problems. It's not just enough to go ahead and do the mathematics. You want to also make sure that you're interpreting what's going on. So if somebody else were to look at this and ask you what's going on, you should be able to tell them as far as profit, and are you making money, losing money at this number of items sold. Okay, let's go ahead and look at one more. Let's look at demand. All right, and we have some customers in a hardware store that are willing to buy so many boxes of nails at however many dollars per box, and our equation is given by n of p is equal to 80 minus 5p squared, and p is bounded between 1 and 4 inclusively. We're going to start off finding the average rate of change of demand if the price goes from $2 to $3. So the price of nails goes up by $1 per box. Okay? And we're going to go ahead and find the average rate of change. So we need to find the value at 3, need to find the value at 2, get our y values. We're going to subtract them, and notice here that our rightmost value, our n of 3, is 35. Our n of 2 is actually 60, and when we subtract those and subtract the denominator, which ends up being 1, we end up with negative $25 boxes per dollar. And so the demand is decreasing because our value was negative by 25 boxes per dollar as price increases from $2 to $3. So you want to specify the increase of price in this case. Yes, the value ended up being per dollar by $1, but you want to specify which dollars it's changing from, because 1 to 2 could be different than 2 to 3. Okay? let's interpret instantaneous rate of change when the price is at $2. So let's see what's going on at exactly $2, where A is equal to 2. And we're going to go ahead, plug that in, and we need to find our N of 2 plus H. We did find our N of 2 already, which was 60. Okay, we're going to plug in our N of 2 plus H, do our foiling, do all the things that we need to do, and we end up with 60 minus 2H plus 5H squared. When we go ahead and plug that in for our instantaneous rate of change and our limit, we're going to go ahead and notice that, again, our 60s are going to cancel out. And we end up with negative 20H minus 5H squared over H. Again, we can factor out a H, and it's going to cancel, leaving us with just the limit as H approaches 0 of negative 20 minus 5H. This part is going to go to 0 because H is going to 0. And there we end up with negative 20 boxes per dollar. So the demand is also decreasing by 20 boxes per dollar when the price is at $2 per box. And again, because we have an interval from 1 to 4, it is important to let us know what price value this is happening at. Now, if we look at part C, as the price increased from $2 to $3, how is the demand changing, and is this change to be expected? Please explain it. All right. What we're looking at is the demand is decreasing. So we want to know first, how is the demand changing? The demand is decreasing. Is it to be expected? Well, of course, because usually a higher price usually reduces demand. If you make the price go up too high, the demand for a product goes down.